Alright, so here's a test for the microcontroller. As you can see, here is the target board, and we put a microcontroller inside of this box. So when we close that, the microcontroller connect with all the pins around. And here is a programmer. So the program has its own power, but so that jumper will decide which power we're gonna use. Right now, that jumper makes a power. We didn't use a power from that programmer, so that makes sure we could use a power supply, the value that we could define by ourselves. So right now, I'm gonna connect that to the programmer. So here's a power supply. Our goal for this microcontroller is 1.8 volts, but since we're gonna lose some power during the wire line out, so I'm gonna just make that 1.9. So, because if the power drops below than the 1.8, the microcontroller won't work anymore. So here is a code for the SPI, and we're gonna debug it first. So that debug has already been successful, and now I'm gonna just run that. So since the module light has already been turned on, that means the code has been programmed to the microcontroller successful. Right now, the things we do is we're gonna make sure the waveform from the pins. First, this thing we're gonna make sure it's a pin 11. It's a port 1.5. It's a clock pin. So as you can see, here is a clock. It is a perfect square wave, and the voltage is about 2.0 volts. That's because the power supply is a little higher than 1.8. And the thing right here is this thing is not stable because this is not clock. This is data that this is a pin 24. That is port 2.0. That pins the output of the data. So based on the oscilloscope, the waveform we got respect, it could be proved that our microcontroller could be programmed, and the output, all the pins we need could be for the SPI could be work successful.